So let's move on next to this backplane board. It's a reproduction of the original MITS board. I think you can see here that the PC board material itself is very thick. It's approximately twice as thick as a standard PC board. That's intentional to give it mechanical stiffness. It's hard to flex. So I'm going to follow the instructions here. Observe, blah, 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 blah. Orient the expander board in front of you with a foil pattern on the bottom. The board designations markings should be underneath in the right corner towards you. They're right here and they're in the right corner towards me. So once he's oriented, so the numbered pins are to the front and the lettered pins are to the back. Let me get some glasses on where I have a better shot at actually being able to read that. So that puts pin 1, this corner down here, through 50 over here, and then the letters are on the back. This should place pins 1 and 50 with the same orientation as 1 and 50 on the board bottom. Yeah, 1's over here and 50's over here. Wow, these little jumper holes are tiny. It'd be interesting trying to lace 2 of these together using them. I'm going to go ahead and do the same thing with this one. I've got 1, that orientation. It's interesting that 1 and 50 up here are marked differently. Orient the edge connectors so the numbered pins are towards you and the lettered pins towards the back, with the pins themselves pointing downward, which is what we've done here. See if I can keep those in place. Now I'm going to just tackle some inside pins first to make sure everybody's in flush. There's actually, if I drug my finger across there or something, there's some discoloration across the center there. And I'll worry about these pins on the ends, these ground pins and power pins at the end, because they're in much thicker copper. So let's give this a shot. See if we can tack these in. And here towards the corners. And again, I put 1 in on each end just so everything would lay down flush and flat, rather than have it rocking back and forth. Actually hit that one. And now I'm going to push and make sure it's in flush. Push and make sure it's in flush. This one doesn't look like it's seated as well as it should be. I'm not sure why. That looks better. There's a little bit of gap between the PCB and the kind of the bumps on the bottom of the connector. So with those 2 in place, just walk down a row of the pins here and solder. Still debating whether I'm going to actually use this back plane in the build or use I've got an 18 slot terminated back plane. I've actually got 2 of them that I'm debating whether using it to give me huge amounts of expansion capability in the cabinet. And I'm excited about that versus getting 4 of these in there to get 16 slots and then doing the wiring between them. Of course, that would be much closer to, you know, the original configuration. I'm not necessarily going for, you know, 100% what it looked like originally. You know, the case and the front panel and stuff, of course, I want as accurate as possible. Inside, I want to be able to run higher speed CPUs, you know, Z80s and that kind of stuff. The backplane board I've got, I think people have ran up to 10 megahertz on the thing. I typically deal with 8080s at 2 megahertz or Z80s at 4. But it's nice to know you have that kind of speed available. If you look at the boards up on the N8VM, or not the N8VM, at S100s.com, if you look at his boards, he's got all kinds of processor boards and support boards. You know, you can run DOS and 6800s, and there's just all kinds of options he's got up there, multi-processor support, that kind of stuff. And it would be nice to have a completed machine in a case that could support that kind of stuff. Now, the Altair front panel isn't necessarily going to be compatible with all of that, but it gives me the option of just having, you know, a 2 megahertz 8080 or a real performant machine if I really want it, you know, by the standards back then. Of course, not by today's standards, where you've got gigahertz processors. And I'll go ahead now, and I will tackle down here. Come on, give me a nice flow. We'll tackle there and there. Again, this is where my JVC pencil comes into its own, just because it's got awesome thermal capabilities. I can tackle something like that. Well, rather than, again, you know, shoot an hour video of me soldering here, I will do some high-speed video as I finish this up, and then we'll come back and take a look at it. Generally it looks okay. I created one bridge that I caught while I was soldering, so I'm going to go ahead and walk through the board here looking for solder bridges. So let's get ourselves in continuity, and I should be able to do this and just walk along. Maybe. Why? That tray should come to here. Okay, what's happening is when I'm down in the hole, because they're not plated through, I'm actually not getting contact. So I need to be a little more particular about this. Just make sure I don't have any solder bridges like up to there. There's a lot of shiny traces and solder down in there, and it makes visibility a little bit rough, and it's better to be safe than sorry. I'd hate to spend hours trying to get a CPU card debugged and discover it's a solder bridge on the back plane. That would be difficult. Oh, slipped off there. Well, let me repeat a few pins here. Assembly wasn't bad. I did manage to burn my finger, but that's what happens when you use hot tools. You get burnt, you get cut. It just happens. That looks like it's just a loose solder ball. That looks good, and I should find end-to-end continuity. I'm not going to buzz these all out. The traces all look fine, but I don't have any bridges or shorts between pins. So we have our motherboard, and we have a card we soldered up earlier, which should slot down in there. Width-wise, it looks good. Yeah, it's just tight. So we got heavy gold plating on the card. Of course, heavy gold plating on the card. These are gold-plated contacts. We shouldn't get oxidization. It's coming together. Very happy so far. So far printed out 2 card guides. Up on Gary's, the planet.org site, there was STL files for card guides that are very similar to the originals that came in the Altair kit. And I'm going to go ahead and mount a couple of these on here just to see what we get. I don't really have the perfect screws for this, but I found some that I believe will work. I'm having some problems with the printer getting with peeling of the the guides peeling up off the print surface on the printer. This has been a problem with my printer from the get-go, and I tune and tweak, and for long narrow parts just never get a print that is completely satisfactory. I'm playing with settings down there, and I'm getting much closer. I guess this would be easier if I had a 1/4-inch nut driver here rather than trying to use a flat screwdriver. Well, that's cinched up well. I'm, I think, generally happy with that. We'll mount the other one here. Why does that seem like the wrong screw? One of these may be a slightly bigger screw than I wanted. Now that screw's just a little bit bigger for some reason. So let's dig again. I thought those matched up really well, but apparently not. See if I can find a match here. I'm digging through a little bin full of screws. I don't keep a lot of self-tappers. It's a little shorter, but it's the right size, I believe, for now. These won't be the final screws I think I use in this. But for now, these will be good enough just for demonstration and testing. So we've got two of the card guides mounted. And of course you would have 8 total on the board here. The next 2 are downstairs printing. And then the card slides into these and plugs in like that. Actually, those look really nice. Those turned out really well. I'm very happy with that. So mechanically that's not bad. Cards in nice and straight. Everything lines up well. It produces nice spacing between the cards. Keeps them from, as Dave Jones would say, flapping around in the breeze, touching each other and shorting together. That's mechanically really nice. I'm very happy with that. That kind of changes my opinion a little bit about using these. I just don't want to spend the amount of money it would take to buy 3 more of these. At this point with 4 slots, I would have enough to get the front panel interface occupies a card spot. Processor, I could get a RAM card in here and an I/O card for driving a serial device, and that would be about it. I might be able to put a RAM-ROM card in here. But that would be about it with 4 slots. It would be difficult, to get a floppy controller in here. Using, the older boards, it would be difficult to get a lot of RAM in here. I've got some 16K RAM cards. Again, they're full size like this. But, 48K of those that occupy these 3 slots. 4 slots just isn't really enough to get a machine. This is more than a very basic machine you can toggle software into and out of. 8 slots gets us closer, but mechanically I really like the way that looks. These would be mounted on a rail set to hold the cards together, then the rail set would be mounted down into the case. At least that's the approach I would take. So really the mechanical stress is through these spots here, and these wings are just kind of floating out there outside of it, but that would make it mechanically really strong. The only downside is, of course, the sea of jumper leads to be installed and soldered. It's very doable. I was hoping some of the S100 connectors here I have in stock would fit the board. These actually have a fairly narrow spacing between the leads in this direction, and none of the connectors I have will work. But I have to say, mechanically I really like that assembly. That's put together really pretty. That's very nice. Well, there's a bit of a look at mechanical assembly card guides. Those are definitely do the job. I printed with PLA rather than ABS, as I don't have a heated bed. But strength-wise, these are absolutely fine. Board sits in well. The height of everything aligns well. Just mechanically, that's really satisfying. I don't know if this is coming through on camera or not, just how nice a build that is. That's just really prettier than I thought it was going to be. I've seen lots of photos, but I've never actually held this assembly in my hands before, and I'm actually really pleased with it. you know, it looks really nice. That's really pretty cool. So anyhow, I think this will wrap up this segment. As I get more parts in, we'll continue the build. So we'll talk soon.